This cake is to be dipped in a very thin covering of chocolate. Find the total surface area of the chocolate needed. Well, we can see that it's going to need this circle. There'll be a circle at the bottom as well. And then we're going to need the curved surface. But it's not a full cone. However, if we just look at a 2D perspective of the side, actually I'm just going to start my diagram a little bit further down the page. So if we look at it from the side, like so, now imagine that it is a full cone. If this is 12 centimeters and this is 6 centimeters and this is 10 centimeters, then by either using similar triangles or some other sort of symmetry type argument, you might reasonably expect that that also is 10 centimeters there. So we could work out the surface area of the curved section of this by doing the big cone and taking away the small cone that I've added to the top. So let's think about the surface area. We've got the big circle at the bottom. The diameter is 12, which means the radius is 6. So that is going to be pi times 6 squared. Here we've got a diameter of 6, which means the radius is 3. So that is going to be pi times 3 squared. Now, let's add the surface area of a whole cone. For the big cone, the radius is 6 and the slant height is in total 20. So pi RL is pi times 6 times 20. But we need to take off this top cone. Now if we think about the top cone, the radius is 3 and the height is 10. So we're going to take away pi times 3 times 10. And now we're in a position to calculate that. So we've got pi times 6 squared, that's for the bottom circle, add pi times 3 squared, which is for the top circle, and then for the curved surface we've got pi times 6 times 20, take away pi times 3 times 10. And we'll call that 424 square centimeters to the nearest integer.